previous lectures, we have been looking at a confidence interval for the population mean mu, but we can also be interested in confidence intervals for other population parameters like the population variance and the population proportion. So in this lecture, we are going to look at the confidence interval for the population variance. And we will start with an example. A machine that manufactures 100 mm steel bolts is set to provide a variation of less than 4.8 mm in the length of these bolts. If the variation in lengths become too big, the manufacturing process has to be stopped and the machine needs to be recalibrated. Now, a random sample of 60 bolts give a sample mean of 99.8 millimeters and a sample standard deviation of 3.89 millimeters. So in this case, the parameter of interest is not so much the population mean, but the population variance. And we would like to find an interval estimate for the population variance and ultimately for the population standard deviation. So in order to construct a confidence interval for the population variance, we have to find a test statistic for the population variance. So for a sample of size n from a normal distribution, the sampling distribution of the following statistic, n minus 1 s squared over sigma squared, is the chi-square distribution with n minus 1 degrees of freedom. Okay, so n minus 1 will be the sample size minus 1. S squared is my sample variance and sigma squared is my population variance. Now we haven't looked at the chi-square distribution up until now. We've been looking at the normal distribution and also the t-distribution. The chi-square distribution can assume only positive values and the density function is positively skewed. The mean and the standard deviation of a chi-square distribution with new degrees of freedom is the mean is equal to the degrees of freedom and the standard deviation is equal to the square root of 2 times the degrees of freedom. Okay, so let's have a look at the chi-square distribution for different degrees of freedom. On this slide, we have the chi-square distribution with 2 degrees of freedom. So here you can see that it assumes only positive values. It's only the horizontal axis only goes from 0. And you can see that this density is positive skew. So it's got a tail towards the right. To see how it will change if we change the degrees of freedom, so we can increase the degrees of freedom. Okay, so for 5 degrees of freedom, you can see that what the shape of the chi-square distribution looks like, and we can increase the degrees of freedom even further. Okay, so for higher degrees of freedom, you can see that the distribution becomes more and more symmetrical and less positive skew. Okay, and here we have an example of the chi-square distribution tables. Like the t-distribution, we have the degrees of freedom in the rows and the probabilities in the columns. Now we will use the chi-square distribution for the confidence interval of the population variance. If x1 up to xn is a random sample from a normal distribution, then a 1 minus alpha confidence interval for sigma square is given by this expression. So it's n minus 1 s square, the sample variance, divided by the chi-square value with n minus 1 degrees of freedom, and then 1 minus alpha over 2. That's the lower limit. For the upper limit, it is n minus 1 s square divided by the chi-square value with n minus 1 degrees of freedom and a probability alpha over 2. So now we can set up a confidence interval for our example. Our n is 60, so n minus 1 is 60 minus 1, 59. S squared, it was given that the standard deviation is 3.89, so S squared will just be 3.89 squared. And then we want to find our chi-square values. So because my n is 60, n minus 1 will be 59. And then my confidence interval is a 95% confidence interval. So 1 minus alpha is 0.95, which means that alpha is 0.05. And alpha over 2 must then be 0.025. So alpha over 2 is 0.025. And 1 minus alpha over 2 is then 0.975. So we will use this to find our chi-square values in the table. Now if you go to the chi-square table, you will see that the degrees of freedom here at the bottom we have 50 degrees of freedom, and then we have 60 degrees of freedom. So we are actually looking for 59 degrees of freedom. Now because we don't have a 59 here, we will just work with 60 degrees of freedom. That's the closest we can get with this table. Of course, if you make use of software, then you can get the exact chi-square value. But for now, we will just work with 60 degrees of freedom. And then first of all, to get my chi-square value for a probability of 0.975. So that's the 0.975. And my chi-square value is 83.3. And then we also look for a chi-square value with a probability of 0.025. And then my chi-square value will be 40.48. So these are the two chi-square values that we will substitute into our confidence interval. And here you can see we do the substitution. And if we calculate, we get a 95% confidence interval for the population variance. Now from the confidence interval for the population variance, we can get a confidence interval for the standard deviation sigma. So we just take the square root of the lower and the upper limit. So if we take the square roots, we get a confidence interval for the population standard deviation of 3.27 for the lower limit and 4.7 for the upper limit. So now we can say that we are 95% confident that the population standard deviation lies between 3.27 millimeters and 4.7 millimeters. And then, based on this sample of 60 volts, it looks like the manufacturing process is therefore under control.